Hello everyone, welcome to the class on galvanic cell. A galvanic cell is an electrochemical cell that converts chemical energy into electrical energy. It makes use of chemical reactions to convert it into electrical energy. That is, it makes use of redox reactions, which involves both oxidation and reduction reactions taking place simultaneously. One species is undergoing oxidation, that means it loses electrons, and other species accepts electrons, that is, it gets reduced. And due to this flow of electrons from one species to the other, electric current will be generated. Okay. Now we come to parts of a galvanic cell. A galvanic cell can be divided into two half cells. One is oxidation half cell or anode, and the other one is reduction half cell or cathode. Both the cells consist of a metal rod which is dipped in a solution of its salt. And these two solutions will be connected by a special arrangement called Saltbridge. Then both the electrodes will be connected through an external circuit. This is Daniell cell is a typical example of galvanic cell. Daniell cell consists of two electrodes, zinc and copper. Zinc will be dipped in a solution of zinc sulfate, which forms the oxidation half cell. Copper will be dipped in a solution of copper sulfate, which forms the reduction half cell. Out of the two electrodes, the zinc will be acting as the oxidation half cell and copper as the reduction half cell. The two solutions will be connected by means of Saltbridge, and we can have a general representation of the Daniell cell as Zn bar Zn2 plus. The two parallel lines represent the Saltbridge, then copper 2 plus bar Cu. This is the general representation. Here it is a diagram for the Daniell cell. Here left hand side represents the oxidation half cell. Zinc is dipped in zinc sulfate solution. Right hand side shows the copper or reduction half cell. Copper's rod dipped in copper sulfate solution. See, the two solutions are connected by means of the Saltbridge, and the external circuit, we can also see the external circuit. Now we come to the reactions taking place in the Daniell cell. As we all know, the first reaction is in the oxidation half cell. Comparing the two electrodes, zinc has more ability to give out electrons. So it gives out two electrons and goes into the solution as Zn2 plus ions. These electrons will move through the external circuit and reach the cathode, which consists of copper. And there, these two electrons will be taken up by copper ions in the solution, and they will be converted into copper and get deposited on the electrode. So, as a result of these two reactions, there is flow of electrons from anode to cathode. So, electrical current will be generated whose direction is in opposite to that of the flow of electrons. And we can represent the net cell reaction by combining these two half cell reactions. Zn plus Cu2 plus gives Zn2 plus Cu. This is the net cell reaction. Now we come to the function of a Saltbridge. We already said that the two solutions of a galvanic cell or a Daniell cell are connected by a Saltbridge. Saltbridge is nothing but it is a U-shaped glass tube filled with a solution of an inert electrolyte. The electrolyte will be mixed with a gel and it is filled in the U-tube and it is kept inverted. The Inert electrolytes used may be KCl, KNO3, potassium chloride or potassium nitrite. They will not react with any of the components of the half cells, but they will allow the transfer of ions from one half cell to the other, thereby maintaining the electrical contact or electrical neutrality. Thus, it balances the charge of both the half cells. So these are the major functions of Saltbridge. So we have seen the function, what is a galvanic cell, what are the different parts of galvanic cell, and reactions involved in galvanic cell, and the functions of Saltbridge used in galvanic cell. Thank you.